Today we'll be solving quadratics by factoring. So in order to be able to do this, we need to be experts of actually factoring quadratics. So we check to make sure that we do have a quadratic, and we do because we have an x squared. So we need to have, and we must have, a 0 over here. And here's the idea I'll show you down here. So if I have two numbers, say a times b, I say those equal 0, then I know that one of these numbers must be 0. That's called the 0 property. So if a is 0, I get 0, and if b is 0, I also get 0 right here. So that's the whole idea with factoring, and it doesn't matter what the other number is. One of these must be 0. Okay, so let's take a look at this example right here. The first step of factoring is to factor out the common monomial. So I see that all these terms here do have an x, so that means I can factor out an x. And essentially what I do here is I divide all these terms by x. So I took out one of the x's, and I took out an x here. So now I have these two things. Now because of the 0 property, one of these terms must be 0, so I will split them into two. I'll say either this equals 0, or this equals 0. Now this one's already solved, so I'll go ahead and finish this one by subtracting 4. And I get negative 4 on that. So I have my solution here. X is 0, or x is negative 4. This one's a little bit trickier, but if we've been practicing factoring, then this isn't too much of a problem. So what I need to do is I need to think of the factors of 6. And the factors of 6 are 1, 2, 3, and 6, plus or minus. And I want the factors of 6 that add, or somehow combine, to negative 5. So I'll write my binomials right here. So in order to get this x squared, that means I multiplied an x times an x. So by distributing here, the first thing, the outer, x times x is x squared. So I have that. So now I need a 6. Now generally, the solution is the two that are closest together, but not always. So I'll start by trying 2 and 3, and this is guess and test. So I have 2 and 3, and if I were to multiply those, the first, the last, so I have 2 times 3 is 6, and I have my x times x, that's x squared. So I need my 5 here, and notice that the 5 is negative. And I do have a positive 6, so a negative and a negative. So if I multiply the inner together, I would get negative 2x, and the outer, I get negative 3x, and I get negative 5x if I combine those. So hopefully that is pretty familiar to you. So I have factored this, so now I continue on with my solving of this. Get the right pen size. Maybe one more. Okay, so this equals 0 or that equals 0. So x minus 2 equals 0 or x minus 3 equals 0. And I solve these by adding 2 right here. So x equals 2, or add the 3. So x equals 3. And there's my solution to that one. So as I factor this one, hopefully we do have to make sure that we have a 0 there. So to get the x squared, I need an x and an x. Okay, so that pretty easy. Now my factors of 8 are 1, 2, 4, and 8. And again, I'll start by testing 2 and 4. So I'll try 2 and 4. Now if you guess wrong, erase and try again. Now this time I have a negative 8. So what that tells me is that one of these is plus and one of them is minus. So maybe like this. So I want to always check to make sure that I factored correctly. So I check my first term. X times x is x squared, so that's good. I check my last term, so 4 times negative 2, that is negative 8. I'll check my inner and outer, so I have 2x, and I have negative 4x, and if I combine those, I get negative 2x, but look, it needs to be positive. So what I need to do is change the order of my signs maybe. So maybe this was a minus 2, and this is a plus 4. Alright, so now when I check, the first is x squared, the last is negative 8, so that's good. And if I check the inner, negative 4x, if I check the outer, x times 4, that's 4x. If I add those, I get 2x. And all I'm doing right there is I'm checking. So yeah, I have a 2x, so that's good. So, this equals 0 or that equals 0. So x minus 2 equals 0, or x plus 4 equals 0. Add the 2, and I get 2. Subtract the 4, and I get negative 4. And there are my solutions there. Alright, so again, we're using the 0 property, and because we're multiplying these, we know that one of those has to be 0. Okay, so now a few other examples. Now, in order to use the 0 property, I must have 0 on one side. So I need to get everything to one side. So in order to do that, I'm going to have to subtract 35. So I get 6x squared minus 35 equals, now bring down that negative x, and then I'll add the x, and I get 6x squared plus x minus 35. Okay, so factoring this one will be trickier, because now I need a 6 in the front and a 35 at the back. So I have a few cases right here. I could have 6x and x, 6x times x is x squared, or I could have 2x and 3x, and 2 times 3 gives me the 6. And for the 35, well, I could have 1 and 35, 5 and 7. So we usually start with the numbers closest together, so I'll try 5 and 7. Now, same goes for the first term here. So sometimes this is the case, where we have 6x and x, the ones that are furthest apart, but usually it's the factors that are closer together. So I'm going to guess 5 and 7 right here. And I see this is negative 35, so because this is negative, one of these is negative and one of them is positive. So let's do the check. So right here, if I multiply that, I get 6x squared, that's good. And if I multiply the last, that gives me 35. And if I multiply the inner, 15x. If I multiply the outer, that's 14x. Now I need these to combine to give me just an x. So what if that was minus? So 15 minus 14x is x. So I know that this 14, the 2 times the 7, that will give me a negative 14, and I know the 15 needs to be positive, so plus. Alright, so that's how you get that, so it's not just all guessing. Alright, so now, I know it wasn't this case. So 2x plus 5 equals 0, and 3x minus 7 equals 0. And now I solve this. To solve this, I subtract the 5, so I get 2x equals negative 5. And then I divide by 2, and x equals negative 5 halves. I add the 7 over here, and then I divide by 3, and 7 thirds. Okay, so that gives us that solution. Sometimes we stumble on the easy examples, so right here I have x squared equals 81. Again, I get everything to one side. Now we could square root right here, but then we need to remember we get both a plus and a minus when we square root. So if I had x squared equals 64, and I did that by square rooting, there's nothing wrong with that. The square root of 64, though, is negative 8 and 8. Okay, so right here, I'll factor, and I notice I don't have a middle term, that means it's 0. So the factors of 81, 9 and 9. One of them's plus and one of them's minus. So x equals negative 9, or x equals 9. So really quick, what if I had x squared minus 25 equals 0? See, this is two perfect squares, and to factor those, we have basically the same setup, but one of them's minus and one of them's plus. And then we would have x equals 5 and x equals negative 5. We have to be careful, though. I cannot factor the sum of perfect squares. So in this case, this will be something that we'll do later, But for now, we'll just say there's no roots for now. No real roots. Okay, so sometimes we'll have, these are not quadratic, these are cubic. And when we get cubic functions, for now, we'll have to factor them by grouping. We need to factor them by group. So what that means is I'm going to take these two things together and these two things together, and I'm going to factor them separately. So when I look at this group, I see that I could factor out not just an x, but an x squared. And I have x minus 5 left. See, if I distribute that x squared, I would get this back. Now plus, when I look at these two terms, I could factor out a 3. And now, when I look, I see that this is common to both of them. So I'll factor that out, x minus 5. Well, then what am I left with? Well, this thing and this thing. So x squared plus 3 equals 0. Okay, so that means x minus 5 equals 0, and x squared plus 3 equals 0. I would usually try to factor this, but like I was just saying, the sum of two things, I'm not going to be able to factor. So I might be tempted to do this, subtract the 3, and then square root both sides. But then I can't square root that, at least not yet. So we're going to say this isn't going to lead us to any real answers. We add the 5 over here, and here's our solution, x equals 5. Alright, so again, factoring by group. Now, I need everything to one side, so I'm going to get everything to the other side. So I'm going to subtract the 30, and I'm going to add the 15. Everything to the same side. And I want to make sure everything's written in the correct order. Now I'm going to lump these two things together and lump these two things together. And hopefully, if this works out, I can factor out, well, what's common in both of these? Well, first of all, I could divide both 3 and 6 by 3, so I factor out a 3. And I could take out up to 2 x's right there. So what's left in here? Well, x, I took out 2 of them, so 1. And then 6 divided 3, that's 2, so minus 2. And then I took both of those out. And then right here, I want to make sure I factor completely, so I want to take out a 15. Okay, and then I see right here, see this is common to both of these, so I lucked out there pretty good. So I factor out that thing, and that leaves me with this and this. So 3x squared plus 15. Now don't be lazy with your parentheses, we need those. And then I see something else is common. I can divide out a 3, so I'll go ahead and do that. Okay, now this doesn't have an x on it, so that means that I do not need to include it in my solutions. If there's an x there, I do. So x minus 3 equals 0, or x squared plus 5 equals 0. And again, I have the sum of two things, a square and a 5, so that means I'm not going to get any solutions from that I need to worry about right now. So I get x equals 3. Okay, I'll do this one last. Let's go ahead and take a look at this one. So this one's a straightforward one. Two groups. How do I get an x squared? X and x. How do I get a minus 2? Well, I'm thinking 5 and 3. So minus 5 plus 3. Okay, let's check and make sure that is actually the case. So do check your factoring. So I do x times x. So that gives me my x squared. And then I have my negative 5 times my 3. So negative 15. So far, so good. That's what I have right there. And then I have the inner. And then I have the outer. And when I combine those, this is what I would get. So this is actually not my solution. I'm just checking my factoring. So check your factoring. Check your factoring. Alright, so x minus 5 equals 0, or x plus 3 equals 0. Add the 5. Now you might think, well, didn't you say the sum of two things? No, if this were squared, then I couldn't do it, but it's not, so I can do it. So subtract 3, and x is 3. So that's good. Negative 3. Negative 3. Okay, right here, this is factoring by grouping, but I must have a 0 right there, so I'm going to subtract the 18. Okay, I'm going to factor this by grouping, so I'll group those two things together and those two things together. Okay, so what can I take out of those? Well, an x squared. And I can factor out a negative 9 right here. So that's going to make that a plus 2. Now, had this been a negative 2 right here, then I would have factored out a positive 9 over here, so that I could have had a negative right there. Alright, so I see that this is common, so I factor that out. And then I have x squared minus 9. So this is a very good problem because the first few examples like this, I wasn't able to do anything because this was a plus, but now I need to factor completely. So if I see something that I could factor again, well, I go ahead and I do that. So I can factor that, so I will. I'll split it into two groups. X and x will give me x squared, and this is the difference of squareds, so 3 and negative 3. Alright, so that means x plus 2 equals 0, x minus 3 equals 0, and x plus 3 equals 0. So x equals negative 3, x equals 3, and x equals negative 2. So those are all solutions of this, and let's just kind of take a look. So remember those, negative 2, negative 3, and 3. So what we're saying when we're factoring these and we're getting the solutions, we're saying, well, negative 2, we're saying negative 2, negative 3, and what was the other one? The other one was positive 3. What we're saying is that we have a graph that goes through these. And these are called the zeros. And to get the zeros, at least for now, what are we doing? We are factoring and getting them. So that all of these answers are where these graphs, if I were to graph them, would cross the axis. It would cross the x-axis.